Okay, cool. Okay. Uh, wow. I It is lovely to see everyone here. Thank you for coming. Can I get a show of thumbs up, middle, down? How are we feeling? I love the honesty. Thank you. Yeah, it's been a hell of a week. It's been a hell of a semester. So just to get started, um, this should be a fairly low-key kind of class. Um, what am I gonna do? Hide floating meeting controls. Okay, what will this class be? This class, we are going to do some data access exploration, which really all that means is I'm going to give you a file type that you haven't seen before that you may end up seeing in when you're looking into your final projects, because files are very common in Astro. And you're gonna open it. That will be your you're gonna open and plot what is inside of this file. Before you guys get started on that, some announcements. Homework 8 is out, and I believe it's due on Thursday. Your final project proposals should all be in. If they are not, shoot me an email. We'll deal with it. It's fine. This is not a normal class. I can and happily do give extensions pretty commonly. If you haven't gotten feedback on your proposal, that's coming. I'm sorry. It's been a weekend, so working on that. We have class on Thursday, and then we have we do have class on Tuesday, but it's just a project work day. So if you can come, just work on your thing. We'll be here to answer questions. Otherwise, if you're traveling or you're like, it's Thanksgiving break, leave me alone, that's fine. There will obviously be no class on Thursday. I hope you all take the break to sleep and rest up so that you are not dying for finals. Are there any other announcements I need to make? Oh yeah, remember that your final projects are due. I believe it's on December 2nd. Because that is when we will start doing our lightning presentations. All that means is you will have 1 to 2 minutes to tell the class about what you did for your final project, and any future directions you'd like to take it. Yeah, and we'll send out a sign-up sheet for slots, like which days you want to go, very soon, before the break. Another thing to keep an eye out for is that we will be hiring interns for next semester. I say interns as if it is a paid position. It is not. But if you would like to do unto others what hath been done unto you in this class, then please apply. It's an incredibly fun experience to teach. And you get to continue to learn as you teach. I learn things from you guys all the time. I know that sounds lazy, but I promise it's not. Okay, let's get started. The idea for this is that you will download a file It should be called, I think, Fitz disk file, probably with a parentheses 2 after it, because I've downloaded it a bunch of times and always forget where I put it. Don't be like me, organize your computer storage system, and know where your things are. You will take it, you will open it up, you will pull the data, and you will plot it. The plot should look something like this. You can play with the aesthetics of it. We will not be answering any questions for the first 10 minutes. And then we'll come back together. We'll talk about the first steps you guys have made. And if the first steps are just, I went to this AstroPi documentation link, and started reading and got confused, that's fine. That's part of research. That's part of coding. It's just a thing. But yeah, I would like to hear from all of you where you got to, and then I'll give a few helpful hints depending on where you are, and then I'll send you off on your way to do the exercise. Yeah. Great question. It should be, oh my God. So if you go to your fall 24, you go to files, should be under discussions. And then, did I not put it here? Oopsies. Oh, I just didn't put it in the discussions folder. Thank you. Yeah, so the folder is just in the wrong place. I won't move it until after, so that you guys can just. So if you go to Intro to Python, Fitz discussion is right here. Cool? Okay. Then we'll put this back up. And I will set a timer for 10 minutes. Feel free to talk amongst yourselves. For those of you watching the video, please pause the video for now and take a bit to start working on this before you move on to our discussion. All right, so let's talk about it. Have we gotten anywhere with this? Actually, let's make this slightly more of a structured question. What happened? So the first step was to download the file. Great. I hope no one ran into issues with that. Second step was to try to open it without Python, better known as just clicking on it. What happened? Weird characters. It actually opened for you? Oh. Well, got a bunch of weird characters. Okay. Anyone else? Yeah. Yeah. Raise your hand if you got an error or weird characters. Good. So Fitz files are interesting like that. Astronomers work with a massive amount of data from day to day. We then need to be able to compress that data into very small storage spaces. But if your file format can compress things very easily, then they can't be accessed very easily. So you need to have a very clever storage system, and it tends to be pretty complex. FITS files, I forget what FITS stands for. I think it's FITS or fast image, flexible image transport system. Yeah, flexible image transport system. It is very useful. We see them a lot, although kind of less so now. Although they are still in use. I think FITS files are definitely still in use. You will still see them out in the Astro world. I don't know how much you'll see them in other fields. But in general, this is a good exercise anyway, because everyone has their preferred format of painful file storage. So once we got this error, what did we do? We Google it. Did we click on the documentation link?
Yeah, I clicked on the documentation link and I downloaded the package or imported the package.
Huh? So what was your import statement? From astropy.io, import fits. Cool. I love it when my import statements run. Yeah. Did anyone else import this package? Thumbs. Yeah. Good. Good, good, good. Did anyone else import a different package? Okay. Yeah. Because you know that you are going to have to plot for this, let me see. Because you know that you're going to have to plot, because you're going to be plotting this, we should also import matplotlib.pyplot as PLT. And then just for kicks, because I always import NumPy as NP. Okay. So we got to this. Some of us imported the fits.io package. Good. Fits.io is, so IO stands for input output. So it kind of tracks that it would be a good package to use to deal with the input and output of a data system. Yeah? One hint that I will give you, if you would like to pursue using the astropy.io method, is that open is a very useful method. And if you look up astropy.table, that is another good method that you can use. So astropy.table, data tables. Okay. I'm going to give you guys another 10 minutes to work with this fits. and maybe potentially astropy.table to continue with this data access that you guys are attempting. Yeah? Okay. But I want to check. Has anyone managed to open up the file and see numbers? Okay, cool. The would you guys prefer, this is going to be a little bit of a choose your own adventure. Would you guys prefer to continue working on it? I see shaking heads, so I'll go through a couple of options here. Yeah, so FITS files, they're weird. That is a pretty normal experience. When I first started my job up the hill, I had to open up FITS files on my own, and I had no idea how to do it. My boss was incredibly wonderful about it, so he helped me a lot. But I want to make sure that you guys have the tools to access difficult data sets. So we're gonna go through it. So let's start with the FITS option. So we have this method called open here. When I am looking through documentation and I'm looking for things to help me figure out a specific data file type, then I'm going to look at these like underlined, hyperlinked things. And I'm also going to notice note. And it says the astropy.io.fits.util.getTestData file path function used in examples here is for accessing data shipped with astropy. To work with your own data instead, please use astropy.fits.open, which takes either the relative or absolute path. So I see then to work with your own data instead, which is exactly what I want to do because I have data. I want to load my data in. Cool, wonderful, great. And so I'm going to click on this hyperlink here. And I'm going to look at this open function. And it tells me that it's a factory function to open a FITS file and return an HDU list object. HDUs are kind of these fundamental objects within the FITS file. That is how FITS files are organized. FITS files are very strict about how you organize things. So if you try to make a new one and you don't do it right, then it'll yell at you, which is really irritating. It takes only one mandatory argument, and that is our file name. So let's do it. And what am I going to do? I am going to look for examples. That is the next most useful part of documentation is examples. Doesn't look like there's too many here. So I'm going to go back because I think I remember seeing, yes. Here is an example of how the .open function was used in the documentation, so I know it should work. So let's do this. My file is here. It's in my desktop because that's where I put it. So I don't want to have to deal with writing out a relative path because that sucks. So I'm going to make sure that my FITS file is in here, is in the same location as my notebook. So we're going to just kind of do what they did here. I'm just going to copy paste this in. Except instead, I'm going to say, I don't remember what I called it. Okay, fits file disk and then 2.fits. Okay, that ran. That didn't throw any errors. That's nice. It's lovely and wonderful. Someone's either really angry or construction. And I think, oh, maybe it's just a chalkboard thing. Okay. So let's take a look at what this HDUL is. Okay, that's not useful. It's really actually very unuseful. But it's something and it didn't throw an error. So let's do it. We have these things called primary HDU and bin table HDU. Primary HDUs are something that every FITS file has to have. You can kind of just skip over it. Let me see. I have actually, haha, yes, hdul.info. That's an interesting thing. So let's call hdul.info. Ooh, good. So it gives me a very nice table of contents. Number 0 is the primary HDU. You can see there's kind of nothing here. Not helpful. But then there's this HDU called the bin table HDU. And it has dimensions. It has 31,023 rows and 2 columns. I'm looking for something that I can plot like this. So I might expect it to have 2 columns. So that's a good hint that I am on the right track. So let's keep that. And let's just kind of use a little bit of Python intuition here. We know that in Python, things tend to be indexed by the number that's right next to it. We don't want to access the primary HDU. It's not useful to us right now. We do want to access the bin table HDU. So let's see if we can access it like this. Voila. Yes, we can. So HDUL1 gives us the second object in the HDUL list, the HDU list, which happens to be this object called an astropy.fits, astropy.io.fits.hdu.table.binge.table.hdu. Cool? Okay. I don't know what to do with this because this isn't numbers. That's not something I can really plot. So I'm going to show you another trick. In Python or in Jupyter Notebooks, what you can do is you can put 2 question marks after something. Can I? Okay. 2 question marks after something, and it'll pop this thing up at you. And it's telling me, okay, I have a bin table HDU. Great. We're going to learn about classes on Thursday. That's object-oriented programming, not necessary, and you will not have homework on it, but it is very useful to know in Astro. So let's look at this. Let's look at this bin table HDU thing. So it has parameters. Okay, cool. It has data. That's good. I like data. One thing that you guys should generally think about when you see something like parameters is that maybe you can access those parameters. So let's call HDUL1. The way to access those parameters is by putting a period after this list or this object, and then after the period, the name of the parameter that you want to access. That's not necessarily going to be the case for everything you do with data access in Python, But in this case, does help. So these are numbers. That's really nice, but they're really weird. What is a Fitzrec? There are these tuples. It's a giant mess. So let's look at the shape of this thing. Okay, 31,023. That means it has 31,000 tuples. And each tuple has two things in it, which is nice because that means we've got two columns. But now I don't know how to access the the data in a way that I can plot it. So let's look around a little bit. Another parameter that I saw is this thing called a header. Okay, cool. Let's try looking at the headers. Oh, that's nice. Why is this nice? Well, if you look at this file here, I have an x-axis that is wavelength in angstroms, and then a y-axis that is flux. And that is exactly what the names of my columns are. So kind of like in pandas, let's see if we can access the data with our column names. So I'm going to copy this. HDUL1, and then paste that. Okay, she doesn't like that. Uh, uh, do, do, do. So now I'm wondering if that will work. So what I did to get this error to play nice with me was instead of calling the column name on this HDU, this bin table object, I took the parameter called data. I got the data from this bin table object, and then I called the column name. And now I have this lovely array of wavelengths. I'm going to spell out wavelengths right. I'm going to set that equal there. If I am going to then also use, if I want to plot flux on the y-axis, then I'll want flux here. Okay, ran without an error. Good. Now let's see if it plots the way that I have it shown here. Remember, we start with our plt.figure sandwich. That's the top bun. And then we say plt.plot wavelengths, comma flux, and then plt.show. Ayo. That's exactly what we're looking for. It doesn't look the same as the one that I showed you here because I changed the dimensions of the figure here. So it's going to look a little bit weirder in this one. And that's how you can get a FITS file out. There is an easier way though. And it has to do with data tables, with this astropy.table thing. So what we're going to do, I don't really work with Q tables. Mostly I work with tables. So instead, what I'm going to do, astropy dot table. Dot. Yeah, this is an object called a table. Takes data. Good. So this is tables. What we're going to do is we're going to say from astropy dot table import table. And we're going to say table dot read fits file disk 2. That's just the name of our file. And run that. That is a very nice and pretty familiar, kind of looks like how pandas data frames look. That's why I like to use tables. They make things significantly easier. To access this data. It does all the work that we did up here for you. Okay. It is 2:56. I will post the solutions to this discussion in a couple of days. And I'll take questions now. But if you are ready to leave, you're welcome to leave. Does anyone have any questions? Yeah.
Is there like a logic chain between like HTML1 dot data? What's like, what is it exactly called?
By what is it exactly called? What do you mean?
It gave you an
Uh-huh.
error dot data. Like, what is that?
Yeah. So the error that I got here was I tried to call HDUL1. I think I tried to do it with wavelength, but it kind of doesn't matter. So if I do that, it's going to give me an error. And it's going to give me an error because this object thing called a bin table HDU is not subscriptable. So not subscriptable is going to be a pretty common error that you'll run into. And it just means it's an object that you cannot reference what's inside of it by a number or a column name. You have to unwrap it before you can subscript into it. Does that kind of make sense? Means accessing it, yes. So I was able to access HDUL1. I was able to subscript 1, or I was able to subscript into HDUL because it's a list. It is an HDU list that allows you to subscript. But the HDU list is made up of these things called HDUs, and you cannot subscript an HDU. What you have to do is unwrap the HDU. And the way you unwrap the HDU is by calling data on it. And so this fits record array is another thing that you may see. And it's just another type of array. It acts very similarly to a NumPy array. A lot of different types of arrays in Astro and in data science in general are going to act like NumPy arrays just because NumPy is so awesome. We all love it. Another hint we could have taken when we saw HDUL1.data is these. These were the names for the columns that we care about, which we saw when we called HDUL1.header. You can find the column names here and here. So now that I've unwrapped it, this thing acts like something I can subscript into. If I subscript using a number, it's going to give me the first tuple, which consists of the first data points that you plot, which is 500 angstroms and 4.35 whatever e to the minus 10. But we can subscript using column names also. Angstroms.
Like all 30-something thousand.
It'll give you all 31,000. I think it was 31,023. Yeah?
And if you put HTUL 0, like that would not.
So HDUL 0 didn't have anything in it. So let's look at it. So if I say HDUL 0 dot data, it's empty. There's absolutely nothing there. Which you can see with this HDUL.info method. It says 0 is a primary HDU with 0 dimensions.
Data table stored with the different HDUs.
So yeah, so there's this primary HDU. I didn't name this one. That's bad practice. But I think I made this one, it was really late and I wanted to go to bed. But yeah, there could be hundreds of data tables. And this is how we like to store them because it compresses it down so far. Does that help?
Yeah, that helps.
Yeah, sure.
Problem.
Uh-huh. Oh, is it for the Python notebook folder?